Thanks. Well, I only got the first part all out of it. Sorry. Um, how do you check this? So yeah, you take the derivative, and what should the result be after you take the derivative of this beast? What should the answer be if it's good?
The integral of 2x e to 3x.
Not the integral, just
Or
the
just,
integral.
okay,
It
got
would
you.
just be that puppy right there that's next to the integral symbol, right?
Mm-hmm.
So you would differentiate it, and you should get the 2x e to the 3x. And if you don't, something happened. Okay, that's how you could check it. Okay. Any questions? So let's recap. You got this brand new theorem. My gift to you today, IBP. If you've seen it before, great, but you got to know it. And it basically says if you have an integral that looks like a product of two functions and it's not integrable using any other technique out there that you know of, then IBP, integration by parts, might be a good candidate. So you identify your u, you identify your dv, and then you got to get the other two ingredients. You need the du and the v. And then after you have all four ingredients in hand, you write down u times v minus that minus the integral of v du. And the hope is that this integral over here is doable by one of the integration techniques you already know, and then you get your final answer. And it's a beautiful thing if it works. You guys ready to try one?
Yes.
Oh, yes, you are. I'm going to put you in breakout rooms, and you and a buddy are going to give this a shot. Okay? Turn your mics on. Just try it. You know, this isn't a test. Just see if it works for you. I'll give you a big hint. Integration by parts. Here's your hint.
Professor,
Yeah.
I think there's like a problem with the reader. I don't know if it's only mine, but for example, when it wasn't 2x e to the 3x.
Oh, is that right?
Yeah,
Mine also has that problem.
Yeah.
And then the next one too.
Mine's too.
Okay, well, they're supposed to get updated. So if you could put those in there, I apologize. I thought I changed that over the holiday break. Yes?
Yes.
And the reason why I put the numbers in there, you have an old version, and I apologize. I wanted these extra numbers or twos or whatever in there because what I found when I didn't have those in there is when students would have a number in there, like, let me just show you what I don't want to see, okay? Because it might get you into a big problem. Let me get rid of this for a moment. If you didn't have this 2 in here, like mine, put it in there, okay? Please put it in there and do it like I did it. Really appreciate it. I'm sorry that your course reader didn't have it in there, okay? But what I would see students do is they would pull the 2 out and then they'd promptly forget about it because they forgot they pulled it out, and they would do their integration by parts, la, la, la. And then they would get an answer and they would get it completely wrong because they trashed the 2 way out in front. And so their final answer, they really needed to bring the 2 back in and distribute it over the entire answer. And so what I decided to show when I was trying to fix my course reader over the break, because I'm always tweaking my course readers all the time, people. And I guess I forgot to update this one for you on my other computer. I got too many computers going on in here. It's a nightmare in this office. I wanted to show that you just leave the 2 in there. Don't pull it out in front. Actually make it part of your U. And that way it stays with you the whole time for the whole entire journey so that you don't accidentally get rid of it or forget about it. Does that make sense? I don't know if that's yes, no,
Yes.
maybe.
Yes.
So I just wanted to stop people from blowing it, and then then the tears start happening and it's like, don't cry. It's not that bad. You didn't kill anybody. Okay, you're good. So leave the number in there. So if you don't have a 5 in there on your course reader, put one in right now, okay? Before I put you in with your buddies. All right. So before I put you in with your buddies, please turn your mic on so you can talk to your buddy, okay? Please, because sometimes doing math via a chat box is like really kind of unfortunate. It's really hard. All right, here we go. I'll see you soon. Honey, are you okay?
What?
Did you figure out what your FedEx is doing?
Well, I think the box has actually been delivered. I think
You're muted.
Professor, your mic's on mute.
Sorry, how about this?
You're good.
Yeah. Some people were going really fast. They got the right answer like right off the bat. Other people were like a little bit confused because, you know, this is brand new. So that's normal, okay? So let's take a look here at how you tackled this problem. So I'm hoping that you identified your U and your DV correctly, because that's kind of the trick. If you do blow that, I don't even look at the rest of your problem. Seriously. If you blow that, I don't even grade the rest. I don't need to. It's like you blew it. So the correct choice for you is that easy little polynomial 5x, and the rest of the integrand cos 6x dx is your dv. So now you need the other two ingredients because you need all four to bake this cake. So you get the du and you get the v. Du is really easy because the derivative of 5x is what?
5 dx.
5 dx, yeah. Now v, you have to be careful. I'm going to purposely do v wrong, and I see this all the time. And if you were telling me what I did wrong, tell me what I did wrong here.
Took the derivative instead of the integral.
Yeah, you're taking derivatives, or almost, because it would be negative. So please don't blow it, because when I see you do a derivative to get the v instead of integrating, again, I don't even grade the rest of the problem. So v is the integral of dv, so you want to integrate the cos 6x dx. So I'll do this in slow motion, okay? If you use the cosine rule, which says the integral of cos u is sine of u. Now, yeah, I know there's a plus c, but I want to tell you something. Anytime you're in the middle of an IBP problem, when you get your v, please don't put the plus c on there. I'll tell you a funny story about that in a moment. But here, using this cosine rule, and I'm using u again, even though I shouldn't, because the real u is over here, but u is 6x, du is 6, dx, so you need a 6. So you put one in, provided you divide one out. Now this integral looks like 1/6 times the integral of cos, which will be 1/6 times sine u, which is 1/6 sine of 6x. This right here, folks, is your v. Now, we don't want to put a plus c here. Well, anytime I integrate, my Calc 1 teacher used to kill me if I didn't put a plus c. Here's the deal. I had a student, this was like back in 2013. I remember it very clearly as if it were yesterday. And he insisted on putting a plus c here. And what happens is that you follow it all the way through the whole problem, and then it's just a mess. And you still will have your plus c, but then you got a big mess, and he would still get the right answer. So I took away most of his points on this one quiz. And I said, no. We don't put a plus c when we're in the middle of doing the by parts, because it'll eventually, it's just too much of a mess. It'll come out in the end, sure, like you did, but that's just not convention, what you did. You can look at any calculus book and nobody does that. And so that tells me you didn't do enough homework. So when we were walking out of the class, he was pretty angry about getting a low score on his quiz. And he was walking behind me. This is when we were still face to face, obviously. And he was talking to one of his classmates, and I could hear him, I got ears. He's like, oh man, that professor, oh, she's just blah, 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 blah. And she took off these points because I put the plus C. And I turned around and I said, Sean, I can hear you, okay? He goes, well, so what? You don't respect mathematics. And I went, okay. And I just walked away. Let me just tell you, I do respect mathematics, okay? I also respect convention, and, oh boy. Okay, so anyway, back to our usual scheduled programming. So hopefully you got all these ingredients for your stuff. So what's going to happen is this integral, which is not integrable right now. It's like, can't do it. Yeah, he sounds pleasant. The audacity, yeah. I had to live with this student for the rest of the semester. And let's just say what happened is He probably didn't get the grade he was hoping for, right? So I grade everybody the same fairly. So then summer hit, and I usually don't teach summer. And then the fall of next semester, I happen to be teaching linear algebra, which you can take if you pass this class successfully. And he was sitting like in the class, and I'm like, well, why is he? I thought he hated me, but I asked him later. I go, I thought I wasn't really your favorite professor. And he goes, well, you're the only one teaching this class this semester. And I went, okay. So he took me again. Amazing. Anyway, so what you need to do is you need to write this as u times v minus the integral of e times du. Okay, that's what you need to do. Okay, so you're going to have to go times minus the integral of times Okay, so what do we put in these blanks here? Okay, what do we got? What do we got? U goes here, 5x, times v, which is over here without the plus c, 1/6 sine of 6x, minus v, got to write down v again, good God, here he is again, times the du, okay, 5 dx. Okay, that's where we are so far. I'll give you at least a couple points if you make it that far. Then what? Let's do a little bit of cleanup. Please clean this up, rewrite it as 5/6x sine of 6x, minus, now I'm going to pull the 1/6 and the 5 out, so I'll have a 5/6 integral of sine 6x. And then you're going to use the sine rule here, and I'm going to put u in quotes because we kind of already used a u up when we did it up here, but I like my u sub, and my du is 6 dx. So I need a 6. I'll put one in, and I'll divide one out. But that means I have a 1/6 out here as well as a 5/6. Yeah, I know. So this integral here looks like sine u du, and using your sine rule, that's going to be negative cos. What did I put 2 x's here for? I don't know. I was talking. Sorry. So this is still looking like 5/6x sine of 6x minus, and then you want to multiply the 1/6 and the 5/6. And sometimes you get some really weird fractions when you do IBP. That's totally normal. Don't freak out. And then this is going to be negative cos 6x plus c. And then clean this up. Just one more step to make it look a little more pretty. A negative times a negative is a positive. Okay. And then you're done. Okay, so how many people got this big old yucky answer as your final answer? I hope everybody. Yes? No? Maybe? Go
Yeah.
vote in
Yeah.
the reactions. Go hit the vote. Yes or no? Yes? Hit the no button if you didn't. Don't be shy. I'm not going to take names. I don't care. Oh, all these people are saying yes. Okay, don't lie. All right, everybody got it? All right, fine. If you didn't, you're too shy. Hopefully it was just a little silly mistake and you got it all figured out, okay? Just so long as it doesn't happen on a big exam. Now, somebody asked me in the breakout room, is this junk going to be on the midterm Monday? Oh, hell no, people. I told you it's only up to and including 8.1. This stuff, you don't even have enough time to digest this stuff. Forget
Thank
this.
God.
Yeah, thank God. This stuff is not going to be till midterm 2. Okay, you're safe. Now,
Thank
let's
you.
keep going. Let's keep going. Okay, this is a really weird problem. Example 3. This doesn't even look like a product. You lied, Professor Rasky. You said that the integrand has to look like something times something, so you could identify who's the u and who's the dv. I lied. Now, I do want to say something here. Do you think that this answer is 1 over x plus c? True or false?
False.
False is correct. Why? What would you tell the person who goes, yeah, I'm pretty sure that the integral of ln x is 1 over x? What is their mistake here?
The derivative.
Yeah, that's the derivative of ln of x. That's not the integral. They didn't teach you the integral of ln of x because you weren't ready, but you are now. Congratulations for making it to today. Today's your lucky day. That's right. You're going to learn how to integrate ln of x. Isn't that awesome? So here's the trick. You're going to kill me, but don't shoot the messenger. Okay. I don't make this stuff up. I just report it. You're going to rewrite ln x as ln x times 1. I know, that's really dumb, huh? Now, who's the u and who's the dv? Now, you may want to go, well, you told us that the u has to be, you know, the most simple part of the integral, so I'll let u be 1. Well, that's wrong. Well, how come? Because du is going to be 0, and that's not going to work. So, wrong choice. Okay, start over. Oops. So, we're going to start over. Doesn't like my erase tool. Sorry. Got to take a quick break. Okay, come on, computer. Get happy. Okay, here we go. So your u is actually going to be ln x. And your dv, I know this is weird, it's weird, is going to be the 1 dx. I know it's weird. Then what? You got to get your other 2 ingredients so you can bake the cake. You need all 4 ingredients to do your IBP. So now you're going to take the derivative of ln x to get your du. So that's 1 over x dx. And then to get your v, you're going to integrate your dv. What's the integral of 1 dx? That's easy, right?
X.
X. Good. Don't say plus c. Now what? Well, you're going to go uv minus the integral of v du. So you're going to go times minus the integral of times Here we go. U times v. So that's going to be ln x times the v, that's x, minus the integral of v times du. So for us, that's going to be x times 1 over x dx. Okay, now remember the whole point was your answer is going to have this weird term, u times v, minus an integral that is actually doable, because the original one is not doable. And please reduce before you integrate. So good news, that just reduces to 1. Ha. And that's pretty easy to integrate because the antiderivative of 1 is x. And so your final answer is x ln x minus x plus c. And we're done. Now don't memorize this. Wow, she taught us the integral of ln x. I better put that to memory. No, you'll just rederive it every time. Unless you want to tattoo that on one of your butt cheeks. I don't care. Okay. Questions? Are you ready to learn Liati? So there's a mnemonic that I'll teach you right now that's not in the book. Liati. It's not a real word, okay? Well, I'll have a cafe liate. No, you're confusing that with cafe latte. It's not the same thing. Go to Starbucks, have a cafe latte. This is liate. So when you're choosing your u, and you've got, you're confused, like who should be the u, who should be the u? The L stands for a log. If there's a logarithm in your integral, the logarithm should be the u. And that's what happened in this last example, is we had a logarithm, ln of x, and he was our u. What does the I stand for? Inverse trig. If there's an inverse trig function in your integrand, like arctan or arcsine, let that guy be the u. What else? The A stands for algebraic. And by the way, this is the order of precedence for who should be the u and who should be not the u. A, algebraic. Well, what's algebraic? Well, when you guys did that problem with your buddy, the 5x, that's an algebraic function. It's a polynomial. And we did let him be the u. So that was a good choice. And then the third choice, or fourth choice rather, in other words, it's not usually a good choice to make your u, is a trig, like cosine or sine. And then E stands for exponential, like e to the x. Okay, so this is Liate, and this is a little mnemonic you can use to help you decide who's got to be the u in this order. Okay, let's keep going. Next up, we have a logarithm 2x. Do you guys have a 2x here, or do you just have an x?
X.
Yeah, crap. put a 2x in there for a reason. God, I thought I changed everything. Okay, so based on my liate, who should be the u?
ln x,
ln 2x.
2x.
Put a
Right.
2x in there. If you don't have a 2 in there, stick one in there for me. Okay, and then what's your dv?
X squared.
Well, yes, but it's 1 over x because he's in the denominator, right? It's the rest of the integrand. This guy right here,
Yes.
rest of the guy, that's your dv. I'm going to rewrite this as x to the negative 2. It'll help me to get the v a little bit easier. And I'm going to change colors because I'm running out of room. Okay. Now let's get the other two ingredients. So du is 1 over 2x, and then using the chain rule, the derivative of 2x is 2 dx. But the 2's cancel. So that's just going to be 1 over x dx. Okay, that's easy. And then v, this is weird. That's going to be the integral of x to the negative 2 dx. So what is that going to be? Is it going to be x to the negative 3?
No. It's just
No.
1 over x.
It's x to the negative 2 plus 1, divide out by negative 2 plus 1, but that's x to the negative 1 over negative 1. But if I rewrite that with positive exponents, that's going to be, come on there, it's going to be minus 1 over x. So I have all 4 of my ingredients now for this problem. There they are. And now I can bake the cake. Okay, except I have no more room left. That always happens. Always happens to me. I never have enough room. Bummer. Okay, so let's, all that stuff down here, you're going to rewrite this as u times v minus the integral of v times du. So you're going to have times minus the integral of times Here we go. Put the right stuff and the right blank. So u times v, you're going to have that logarithm times the negative 1 over x. Okay, so you're going to go ln 2x times negative 1 over x minus v du. So v ended up being what? Negative 1 over x. And du was 1 over x dx. So this is what we have so far. And then clean this up. I always like you to put this algebraics in front of your transcendentals. This negative, I'm going to pull it out in front. So now I have a negative negative. And then when I multiply 1 over x times 1 over x, I get 1 over x squared. And that is integrable because look, then I'm going to turn the minus minus into a plus. This is just x to the negative 2, but we just integrated x to the negative 2, didn't we? Wasn't that negative 1 over x? And then we finally put a plus c, and I'm done. And this is the answer. Now, there are some people who have this big thing about combining everything into one fraction. I personally don't, unless I need to, like unless my back's against the wall and somebody has a gun to my head. I don't. But if you'll notice, both of these terms have an x, so they have a like denominator, in other words. So if you want to, and you don't have to do this, I don't care. You could combine those first two terms into one big old quotient. But I'm not going to give you any extra brownie points for it. So do it if you want, but I'm not requiring it. Any questions so far?
For the first answer that you boxed, should we change the plus sign to a negative? Or
I don't care. I'm
Okay.
okay with plus negative, or if you want to change adding a negative into a minus, that's cool.
all right.
It's good to go. Perfect. Either way. Anybody else? Because you don't respect the mathematics. Sorry. You know, I have so many weird stories over the years that one time I was telling a story and somebody said, why don't you write your memoirs? And I went, no, that could implicate some people, you know. I don't want to go there, but I probably could write a book of all the weird things that have happened. Okay, remember polynomial long division? Here's a tip. Do you think there's going to be a polynomial long division problem on the exam Monday?
Yeah,
Yes.
Do you think there's going to be an arctan problem on there?
yeah.
Yes.
Do you think there's going to be like maybe a split up trick?
No.
Yes.
Yeah.
Mm-hmm. Yeah, you're going to have like, you know, it's going to be like when, you know, well, I guess buffets are not okay since COVID hit, but I used to love to go to Soup Plantation, and I'm so sad they went bankrupt due to the pandemic because that was one of my favorite restaurants. But, you know, I'd go in there and I have one of these, one of those, two of these, two of that, you know, one of everything, you know, it's all good. That's what I'm going to give you for your exam. Like, you know, you're going to get one of everything on there. You're not going to get two of everything. So if like in the middle of the exam, you find that you use the exponential rule twice, for example, stop yourself, go like this, wake up, wake up. Why did I get two exponential rules? Yeah, you're only going to get one of each, not two. Okay, something went wrong there. Review your work. Okay. And you're only going to get one polynomial long division. If you find yourself doing two on the exam Monday, again, wake yourself up, you know, grab your coffee, take a few sips of your tea or whatever, stop yourself. Don't do two of those. Okay, you're going to need IBP and polynomial long division on this next problem. Yeah, I love this double whammy. Right? Are you crazy? So based on Liate, what should be my U?
Natural log.
Mm-hmm. And then my dv is the
X.
rest. The rest of the integrand, x dx. Okay, now I go get my other two ingredients. I got my du. Well, the derivative of this log is 1 over x plus 2 dx. And then v is the integral of x. Not too hard, x squared over 2. Got all my four ingredients. Great. So then what? IBP, u times v minus the integral of v times du, times minus the integral of times All right, fill in the blanks. Okay. U, that's my logarithm, times v, okay, that's x squared over 2, minus the integral of v du. Oh, x squared over 2 times 1 over x plus 2 dx. Okay, people. What the hey? Clean it up. Always put your algebraics in front of your transcendentals, just because it's by convention and it looks nicer. You don't want anybody to think that guy is part of the argument of your log. Minus, now this 2 here, you could distribute it, but that would be bad form. It's easier if you pull it out in front and just make it a multiple. And then it'll be easier for you when you do your polynomial long division. I don't like to have a leading coefficient there in my divisor. It makes your polynomial long division really painful. It's already painful. You don't want to make it more painful. Like, try to minimize your pain, okay? As in life, try to minimize your pain. You're going to have pain, unfortunately. Okay, so this integral is not integrable yet. You need to do polynomial long division on it. Oh no, why? Because it's an improper rational function. It's a polynomial over polynomial. That's a rational function. And the degree of the numerator is, when it's greater than or equal to the degree of the denominator, improper. So here we go. How many times does x plus 2 go into x squared? That's the polynomial long division. Keep your eyeballs on the high power terms only, and then start. X times what gives me x squared? Anybody want to guess?
X.
Yep. So you put an x up there and you start your quotient, x, and you multiply this x with the entire divisor. So x times x is x squared, x times 2 is 2x. Put a minus sign here. I put parentheses just to remind myself I do have to distribute. So x squared take away x squared, nothing. 0 minus 2x, negative 2x. Am I done or do I need to keep going?
Keep going.
Why? That's correct.
Because the same, what is it called? The power of the 2x is the same as the x plus
Good.
2.
Very good. Yeah, this degree is a 1, this degree is a 1. You ain't done. Keep it going. Okay, so x times what would give me negative 2x?
Minus 2.
Yeah, minus 2. So put a minus 2 up top here, and then multiply the minus 2 with the entire divisor. Minus 2 times x minus 2x. Minus 2 times 2 is minus 4. Put a minus here, put parentheses, remind yourself to distribute the negative. Negative 2x, take away negative 2x, nothing. 0 minus a minus 4. 0 minus minus 4?
4.
4. We're done. This is the remainder. This is the quotient. This is the divisor. When you rewrite your integrand, it's got to be q plus r over d. Don't ever forget that. Okay, so what? Well, we still have this x squared over 2 times ln x plus 2. I'm just going to continue to write it so I don't forget it. We still have this 1/2 sitting out in front of this integral, which is going to look like the following. Ooh, I better leave myself some room. Q plus r over d, remainder over divisor. Okay, and this integral is integrable because it's a Calc 1 integral, actually. Don't forget this half. The antiderivative of x, easy peasy, x squared over 2. The antiderivative of negative 2, negative 2x. Plus, how am I going to integrate this 4 over x plus 2? What rule?
Natural log.
Yeah, log rule. So you're going to go u is x plus 2 and du is dx, and so we don't need anything. And so this is already looking like 4 times 1 over u. Oops, that's a u du. This u is not to be confused with the original u. So you'll have 4 ln of u. We'll put the u back in. And then don't forget your plus c way out here. I'm going to clean this up just a little bit by distributing this negative 1/2. So my final answer, which is pretty, I know it's pretty bad. Oh my goodness. Oh, yuck. And then I'm going to reduce that guy. Plus c. Man, that was crazy. Now, for those of you who are like, oh, that problem is just too hard, I'm going to ignore it. No, don't ignore it. When I teach Math 122, which is calculus for poets, it's applied calculus, mostly for biology majors. They do this IBP, and they do this problem in their book. If they can do it, you can do it, because those folks usually are not really big fans of math, and they have a tough time. Okay, questions? Moral of story, double whammy. You had to use IBP and polynomial long division in the same problem. Look at how long it took us to get the answer. Yikes. But hey, we got it. And we win the game. And we win the game. Woohoo! Oh, it gets worse, but I won't even go there. Okay. You guys remember differential equations? Do you think there's going to be a differential equation on the exam Monday?
Yep.
Oh, yeah. Do you think it's going to be an IVP, an initial value problem? IVP, not to be confused with IVP. Yes, it is. So this is good review. Although you won't have this type of problem because this is going to involve IVP. Okay, so let's just take a look at this differential equation. They're not going away. Like, don't go, oh, thank God that's over. After this exam on Monday, I hope I never see differential equations again. And I'm here to tell you, yeah, you will, because they're everywhere. And if you're a physics major, ooh. Physics is differential equations, baby. I mean, if you look at F equals ma, that's actually a differential equation. That's one of the first things they teach you in physics. Force is equal to mass times acceleration. What do you mean it's a differential equation? Well, acceleration, people, acceleration is the derivative of velocity. Ooh, really? Yeah, so that is a differential equation. Haha. Okay, back to reality. Can you say separate the variables? Good. I'm glad you can. So here's what I'm going to do. Let me just rewrite this. Ln x to the fifth. How come I don't have this in my notes? You know, I hate when I do this to myself. Okay, never mind. Whatever. I'm going to rewrite some of this. So if you don't mind, square root of x times square root of y is the way the denominator can get rewritten. And you want to, because you need to separate the variables. Okay, I'm going to use a log property, which says you can bring this 5 out in front. That's legal. I'm going to multiply both sides by dx to move him to the other side. I'm also going to multiply both sides by square root of y to move him to the other side. So after I do all the moving, you know, I'm doing a lot of stuff at once. I claim the variables are now separated. Yay, success. So what does that mean? Well, it means that you can now integrate both sides, right? So that you've got on the left-hand side, you've square root of y dy, which I'm going to rewrite with exponents because I can. So when I integrate both sides, I'm going to go, and I'll pull the 5 out front. Okay, so there is your integrating both sides step. Now the left-hand side is easy because you're going to just use your power rule. So you're just going to go, okay, the integral of y to the half, I think is 2/3 y to the 3/2. Fine. And now this side, 5, and I did say you should leave your 5 inside. Let me leave the 5 inside because I know I'm going to probably forget it. I'll screw myself. Okay. So you're going to need IBP. So using Liate, who's your u?
Ln x.
And then who's your dv? The rest. The rest of the integrand. Fine. Go get your du and go get your v. Well, derivative of ln x is just 1 over x dx. V is going to be 5 times the integral of x to the negative 1/2. But we just kind of did that. It's going to be, well, oh, actually, that's going to be 2 x to the 1/2. Yeah. So v is going to be 10 square root of x. Okay, so I got all my 4 ingredients now. So I'm doing sort of scratch over here on the side. And then I'll come back to my dE over here. So I'm going to wait. So my scratch is, I need to rewrite this as uv minus the integral of v times du. So I'm going to have ln x is my u. Multiply that with my v, 10 square root of x, minus v, 10 square root of x, times du, 1 over x dx. Okay, now what? Well, clean it up a little bit. Now I'll pull the 10 out. I'm going to simplify this. And when you reduce this to lowest terms, you get x to the negative 1/2. And we just integrated that. So I'm going to do it again. And that was 2x to the positive 1/2. Okay. And then the last step of cleanup here. This is a hellacious problem. What was I thinking when I put this on here? Good God, man. Of course, plus c. Put all this crap up here now. So you're back to the differential equation that you were in the middle of trying to figure out. And you got kind of off on a tangent there trying to get your IBP handled. Okay. If you make it this far, I'll give you partial credit because you have the initial solution. It's implicit. But you have 2 choices here. One choice, solve for y, then get c. The other choice is get c, then solve for y. It doesn't matter how you roll, whichever you're most comfortable with. Either way, you should get the same answer. I'm going to get my c right now. How? I'm going to use this initial condition. So y of 1 equals 9 to get my c. So you're going to do some substituting here. So in place of y, you're going to put a 9. And all of the x's, you're going to replace them or substitute with a 1. Okay? Get rid of this. Oh my goodness. So ln of 1 is 0, so that goes away. A 9 to the 3/2 is the same as square root of 9 cubed, which is 3 cubed, which is 27. So 27 times 2, I believe, is 54. Yeah? You can even reduce that. What am I thinking? Let's reduce it right now. That reduces to 18. Okay. Now what? That's equal to, equals 0 minus 20 plus c. So, 0 minus 20 plus c. We'll add 20 to both sides. Okay. And I get c is 38. Is that the final answer? No, it is not a final answer. Oops. What it is it gives you your y or a little bit more oomph here. So over here, you're going to rewrite this, but you're going to replace your c with this number 38. So this is what you have so far. 2/3 y to the 3/2 is equal to 10 square root of x, ln x minus 20 square root of x plus 38. Oh my God, that's nuts. Okay, solve this for y. Ugh. Okay, so I'm going to have to get rid of the 2/3 by multiplying both sides by the reciprocal. Yikes. I know. Distribute and reduce.
See you later.
See ya. My hubs is leaving here. I don't know where he's going. What's 38 divided by 2? Quick! 19. What's 19 times 3? Quick. 57. Okay, I'm almost done. How do you undo a 2/3? What do I need to do to both, or excuse me, this is 3/2. What do I do to both sides to undo raising a power to 3/2? What do I do to both sides? And then we'll finish up for today.
Both sides
want
to 2/3.
reciprocal?
Yeah, you raise it to the reciprocal. So you're going to go, okay, this big mess. Trying to solve this differential equation. Oh, now Zeke is crying. Ugh. Okay, and your final answer is this mess, 15 square root of x ln x minus 30 square root of x plus 57 to the 2/3. Woo! That's nuts. Okay, and we're done for the day. Let's put a stop to it, and we'll pick up more IBP on Wednesday of next week. Monday, you're taking an exam. Make sure you get there early. If you check in late, that's going to cut you off early, because I need you to finish by a certain time. So don't like meander in at, like, oh, 10:30, oh, hi, I'm here. And like, you may not get the full amount of time to complete. I am going to give you like extra time to complete your exam, like even past 11:30 or 11:40, it's going to be, you're going to get a big chunk of time to finish your exam. I want you to do well.
Thank you.
Okay. I want you to do
Thank
great. Make me proud. Okay. Make me proud. And don't forget to upload your handwritten work within 15 minutes. Pow, give it to me. Nice, all in order, nice and neat. Beautiful. Okay. So I'm going to stop the recording there, and I'll stick around for any last